So in this module, we'll be talking about the scientific method, or the systematic, organized series of steps that we use in the sciences, including the social sciences and including sociology. The scientific method is used even by sociologists to try to assure objectivity and consistency in our studies and results. So you might be thinking that, considering that most people will never actually conduct scientific research, why is it important to understand the scientific method? And as I said in the overview, it's important because it's one step to understanding how information is collected and what questions we should be asking about any information or data that we are privy to. And especially when it comes to information and data that might help us make a decision about who we vote for, or where we live, or even where we work. So you might notice that in this module, I'm going a bit out of order compared to your textbook. Don't worry about that. A lot of the content will overlap, but it might just appear in a different order, and you might have some different figures. And that's because I wanted to make sure that I gave you some alternatives to look at. So here, I want to start by talking about deductive and inductive approaches before we get into the stages of the scientific method. For sociologists, we typically start with either for our research. We might start with a deductive approach, which really reflects the typical sociological scientific method experience. Here's where we start with some ideas. We have a theory of some sort. We form a hypothesis or educated guess, and then we analyze data to confirm or reject that hypothesis. We can also start from a different area where we actually start with the observations and the data, and then work on grounding that and forming it into a theory. As an applied sociologist, I've done both. For a lot of my academic research, I often use a deductive approach. And for much of my applied client-based research, I have done inductive approaches. So really, not one is better than the other, and they're both acceptable. But it is important to understand where we're starting. So when we start to describe how we've done our research, we'll be pretty clear about what kind of approach we've used. Another thing that I want to point out is the difference between causality and correlation. Often when we think about research, we are looking for causation. We want to see a connection in which one thing leads to another, right? That's called a causal logic, or a causation. One thing is causing another thing to happen. However, this can be really difficult in sociological research because often the variables that are involved, or the elements that we're looking at, don't necessarily have a time order sequence where one particular thing occurs and then there is a specific consequence as a direct result of that occurrence, right? Or basically that one thing leads to another. Instead, what we're typically looking at is correlation, right? And with a correlation, you can have causation, but not every correlation leads to causation. Correlation exists when a change in one variable coincides with a change in another variable. There could be causality, but it's not certain, right? And that could be because either variable could be causing the other to change, or that there could be an exogenous or outside variable that is impacting both variables, right? So it's really important that you acknowledge this, right? So here's your example that's given in this figure, where typically we would think nutrition leads to height, right? So the more nutrition you have, the more height you'll have. The less nutrition, the less height. And we can't say that this is a causal relationship because there could be other factors that are influencing this relationship. And so it could be a correlation. right? We could say that someone with more height will have better nutrition, maybe as a result of being bigger or taller. We could say that someone with good nutrition could have better height. But also, we can see that there could be some exogenous variables like infection that could impact both of these variables, nutrition and height, and cause a change as well. And typically, we all refer to that as a spurious relationship, which is a pretty cool word. If you want to go impress your friends, then talk about how something has a lot of spuriousness or something like that. So now that we got those two things out of the way, I want to look at the stages of the scientific method. This is a very similar figure as the one in your textbook, but much more descriptive, and that's why I chose it over the one in the text. There are two things that I really want to emphasize on this slide. First, the idea of conceptualization and operationalization, which are pretty much connected. And then second, the importance of population and sampling. With conceptualization, really the term is what it says it is. It's a focus on clearly stating the concepts that you're going to be studying in your research, right? So what are the concepts and what do they mean? For example, when it comes to social science and sociological research, we often use concepts that are abstract and that can have many different meanings. So it's really important for you to state what those concepts are, to determine the meanings or to state those meanings so that your audience knows this is what I mean by X, and to make sure that you come back to those and stick with them throughout the entirety of the study. Another important concept along the same vein is operationalizing your variables. Because again, we have all of these abstract concepts. And so we have to create an operational definition, like a very specific and precise set of parameters describing how we're going to measure that concept, right? So, for example, we have a concept like education. Well, let's operationalize that concept. What do we mean by education first? There's a conceptualization. And then how are we going to measure it? What are the parameters that we're going to use for education? So perhaps I'm going to define education as exposure to an educational system or participation in an educational system. I'll operationalize that term by saying that I'll measure education based on your GPA. Or perhaps I'll measure education based on the number of years of schooling you have successfully completed, right? And so this clarifies things. And when you see research that says, like, for example, the morning news, those like shows that come on after, the morning news, like Good Morning America or the Today Show, are famous for talking about all of these researches. And a new study has come out that says that happiness can be increased by, and this is a famous one, it goes back and forth constantly, by eating chocolate or drinking wine, or health can be increased or something else. There's always something. And you want to ask, wait, how are they using this concept and what's the operationalization, right? Don't just trust that information and start thinking, oh, let me make sure I pound down some chocolate later on today. Okay. Now, on the other side, another question that you should be asking about studies and how they employ the scientific method is, who is the population that they're wanting to look at, and how did they collect the sample? Most of the time, we cannot study an entire population, almost impossible to do so, or impossible. Even the US Census is unable to capture the entirety of the population because, again, people are unpredictable and we're constantly moving. There are constantly people coming in and out of the population. People are being born, people are dying, people are immigrating. And so at no point can we easily capture an entire population. Now, while SRJC isn't the same as looking at the entire United States, it can be difficult as well as people register, drop courses, things change constantly. So from even if you tried to get a snapshot of all of the campus in one day, it would be probably impossible. So instead, we typically conduct a study by pulling out a sample, right? Those samples can either be random or non-random samples. So with a random sample, that means that everyone in the population has an equal chance of being selected to participate in the study. Random samples are difficult to collect. No matter what form of research design or method you use, there's always some sort of obstacle. If you're doing surveys and they're by telephone, not everyone has access to a phone, right? And there are some people who are going to be more likely to want to participate in a study than others. One thing that we found with phones on landlines, back in the day, we used to have these phones that were connected to the wall, right? And we found that older people were more likely to finish a phone survey. Women were more likely to finish a phone survey. And a lot of this is just about socialization and the social environment, right? Women are less likely to be encouraged to be impolite or to think that it's, impolite to not participate. They're less likely to be rude or to hang up in someone's face. So luckily for us, that means we get some completions, but typically that means that now our sample is going to be heavily female and won't be representative. I typically use non-random sampling, and usually that means that I just use a convenience sample, which means that I just use the people who are available to me, or that I might use social media or something like that to recruit subjects. It's not random. There's not an equal chance for everyone to participate. And that means that the population that my sample is going to represent is very specific, which is fine as long as you make that clear and as long as you don't try to deceive your audience by telling them that it is a representation of people that aren't represented in that sample. So now that I've got those really important concepts out of the way, I'm going to go back through the scientific method, which is probably very familiar to you. You have probably been studying it and hearing about it since at least the 6th grade. And, there's a reason why, and that's because it is interesting and it is important. So typically, if we're going through a deductive approach, we start out with an interesting thing that we note or that we stumble upon. We get an idea and we come up with a research question, right? The next step is typically to state some hypotheses about that or educated guesses, sorry, not guests. And so those hypotheses are usually speculations. They are testable assumptions. And typically we're looking at a connection between variables. Often we use if-then statements. If this happens, then this will happen, right? And those variables in the if-then statements have particular expectations that go along with them. So first, there's the independent variable, or the IV, which is the variable that is caused or is expected to cause an influence, right? This is a measured factor that the researcher believes has an impact on the dependent variable. Then we have the dependent variable, or the variable that's expected to change depending on the manipulation of the independent variable. And so I like to remember the difference between the two by thinking of how the independent variable influences, which also starts with an I, or how it's independent, right? How it's not depending on others. And then the exact opposite for the dependent variable, and that it depends on the independent variable. And so it's the one we're looking for change in as a result of our manipulation of the independent variable. right? So again, the researcher believes that the independent variable predicts or causes changes in the dependent variable. And above, you can see some relationships that are being stated here. Now, some of these are causal, and some of them are actually correlations. So you might want to take a moment and pause and decide which is happening here. Is this a causal relationship, or is this a correlation? Finally, I want to introduce you to three more terms that are important: validity, reliability, and generalizability. Validity is simply measuring what you say you're going to measure. If you operationalize a variable and say that this is what you're looking for, your study is valid if you indeed measure that thing. So if I tell you that my operationalization of education is years of schooling, right? Exposure to the educational system, then that's what I need to study, right? And so how I use this variable in my study needs to be in line with that operationalization. I can't say, okay, well, I can't find the years of data, so you know what? I'm going to change it. I'm just actually going to see what proportion of the population is literate and knows how to read. No, right? It's not valid. You're not measuring what you say you're going to measure. Another important term is reliability, and that's consistency of results. And reliability is increased the more information you give about your methodology, your research design, and how you've carried out a study, right? How did you collect those observations? Give us every detail of what the environment was like, when it was done, who was in your sample, who is the population, what statistical tests and analyses did you use to get to your results, okay? This is really important because it tells us how likely you are to obtain the same result using the same measurements if you're in a similar environment and the conditions are the same, right? If a study isn't reliable, it makes it much more likely that someone can come in and invalidate your study, or basically, create an argument that makes your study kind of useless. And so you want to admit everything. It's really hard to replicate sociological studies anyway, because the social environment would have to be exactly the same. But still, it is important that we are giving everyone all of the necessary information and not trying to hide anything. Finally, we get to generalizability, or the extent to which we can claim that our findings are applicable to the group that is represented. And that goes back to that sampling and population connection, right? If our sample does not actually represent that population, then our results are not generalizable, right? Then we can't actually apply them. If I only study high schoolers, I can't go and say, oh, we can apply these results to people who are 25 through 44 years of age, right? You just can't, right? And so those results are not generalizable.